We have another solar flare yet again coming at us, and the images are stunning. NASA Solar Dynamics Observatory photographs the sun when, with 10 times the resolution of high-definition television. NASA's orbiting Solar Dynamics Observatory SOHO captured another solar flare blasting from the same overactive sunspot, and it triggered radio blackouts and stunning aurora displays on Earth earlier this week. And we'll see a map of what exactly has taken place where. You'll see that the highest frequency affected by the absorption is over the United States, Mexico, and most of it in South America, as you see from the map right here. Now, the spacecraft, which watches Earth's parent star, the Sun, from 22,000 miles away, that's 36,000 kilometers, above the planet's surface, captured the flare, is classified as a medium strength type M on Thursday, March 31st. The Solar Dynamics Observatory images the Sun's entire disk across a range of wavelengths every 10 seconds, and it provides pictures with a resolution 10 times higher than that of our high-definition television, according to NASA. The colored image in particular shows a flare in the extreme ultraviolet part of the spectrum that highlights its high temperature. Now, an M-class flare is a fairly powerful flare and a sudden release of electromagnetic radiation of the sun that travels at the speed of light. The U.S. National Oceanic Atmospheric Administration, NOAA, ranked the Thursday flare as an M9.6, meaning it was not too far from becoming as the strongest type, which is an X-class. So this is a very strong solar flare. The flare caused a moderate radio blackout as it hit Earth, NOAA said in their statement. Solar flares can disrupt high-frequency radio communications as the X-ray and extreme violet radiation they emit ionize the upper part of the Earth's atmosphere, the ionosphere. The ionosphere extends from 30 miles, that's 48 kilometers, to 600 miles, that's almost 1,000 kilometers above the planet's surface, and it includes the uttermost atmospheric layers, the exosphere, the thermosphere, and parts of the mesosphere. Under normal circumstances, high-frequency radio waves which transmit communication signals across long distances bounce off particles in the upper ionosphere back to Earth, but when a solar flare charges up the lower ionosphere, the radio waves lose energy as they pass through the atmosphere, degrading or even absorbing them. A moderate blackout can disrupt, as we can understand, the communications for tens of minutes, and according to UK's National Weather Forecast, the Met Office, this type of blackout affects mostly aviation and marine communications, also radio amateurs and shortwave broadcasting stations. The ionization can also disrupt transmission of signals from navigation satellites such as the US GPS network. The magnetically complex sunspot is 2975. It gave birth to the latest flare, has spurted out about 20 solar flares over the past week, including an X-class flare that blasted from the sun Wednesday, March 30th. A few of these flares have been accompanied by coronal mass ejections, CMEs, which are expulsions of magnetized plasma from the sun's upper atmosphere, the corona. CMEs travel much slower than the flares and usually reach Earth within a few days of forming. When a CME arrives, it may disrupt our planet's magnetic field, triggering beautiful northern and southern lights, auroras. On Wednesday night and Thursday early morning, sky watchers reported stunning auroras over Canada and northern parts of the US and in New Zealand. And according to the Met Office, another CME, this one associated with Wednesday's X-class flare, is due to hit us today and will likely give the polar lights another boost. So, because Earth's magnetic field is the weakest above the polar regions, the charged solar plasma penetrates deeper into the atmosphere in these areas, and the interaction of the charged solar particles with the particles in Earth's atmosphere results in the glowing spectacles. So the stronger the CME, the farther from the poles auroras can be observed. So if you can head poleward and away from city lights over the weekend and, well, even today, and check out what you can see. And according to space weather, the grazing CME impact, the coronal mass ejection hitting us today, weak discontinuities in solar and data suggest a grazing impact. This appears to be the CME launched by X 1.3 class solar flare March 30th from sunspot AR 2975. Minor G1 class geomagnetic storms possible as Earth's magnetic field reverberates from the glancing blow. And the solar air radio burst and radio blackout last Wednesday, March 30th. The sun did two seemingly contradictory things at once. It produced a loud radio burst and at the same time caused a deep radio blackout. Both were side effects of the X 1.3 class solar flare. And let's listen to the radio burst. Okay, this is the radio burst that we're talking about. Type 2 solar radio emission, shortwave radio blackout. Now, the gentle roar of static we heard emerged from the loudspeaker of a shortwave radio receiver in New Mexico. Amateur astronomer Thomas Ashcroft recorded it. The sun was well conditioned, he said, in my radio antennas for the X 1.3 solar flare, said Ashcroft. The left channel of the audio file is 22.2 megahertz and the right one is 21.1 megahertz. This is a type 2 solar radio burst. Shock waves from the flare rippled through the sun's atmosphere, creating plasma oscillations that emit shortwave static. Briefly, the sun turned itself into a natural radio transmitter. While the sun was busy creating radio waves, it was equally busy wiping them out. Radiation from the flare ionized the top of Earth's atmosphere, preventing terrestrial radio stations from bouncing their signals over the horizon as usual, and the maps show where man-made signals suddenly faded. Ashcroft's Observatory, New Mexico, heard the blackout. The Gainesville, Florida radio astronomer Francisco Reyes recorded the blackout as well. He said, I used an array of 4 dipoles. And as we said, you can watch the auroras today as well. Okay. We have a coronal hole as well. Solar wind flowing from the minor southern coronal hole. And that should reach us April 3rd to 4th, according. So we have another one. It's not just today, it's tomorrow and the day after, according to space weather. Please leave your comments and thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.